Learn why we use transformers between the point of power generation and transmission, and again near your home or business, how they work, including step-up and step-down transformers, and how they're built. The transformer was developed by William Stanley to solve the problem of transmitting electricity efficiently over long distances. A transformer is used to change the voltage between two separate circuits using induction. A step-up transformer increases the voltage of electricity in the transmission power lines to allow electricity generated at the power plant to be transmitted long distances to where it is needed. Transmitting electricity long distances is less expensive and more efficient at higher voltages. When the electricity arrives at your home or business, the voltage is stepped down, decreased, through a transformer to a lower voltage. At the power plant, transformers increase, step up the voltage, and then when needed for your home or office use, the voltage is reduced, stepped down to a safer level. Voltage ratio. The voltage of the coil windings in a transformer is directly proportional to the number of turns on the coil windings. The voltage ratio is expressed as the relationship of the primary voltage to the secondary voltage. A voltage ratio of 1 to 4 means that for each volt on the primary, there will be 4 volts on the secondary. This would be a step-up transformer, as the voltage on the secondary side has increased. A voltage ratio of 4 to 1 means that for every 4 volts on the primary, there will be 1 volt on the secondary. This would be a step-down transformer, as the voltage on the secondary side has decreased. Three-phase transformers. Using a three-phase transformer is like a single-phase transformer, except that we have 3 single-phase windings instead of 1. With these 3 windings, we connect them together in a Y or delta configuration or a combination of the two. The three-phase power is the most common way that power is produced. Large-scale power plants generate voltages of 13 kV or higher. This electrical power gets sent over the transmission wires at much higher voltages of 110, 132, 275, 400, and 750 kV. These voltages are increased by three-phase step-up transformers for higher efficiency transmission. The transmission voltages then arrive at the load centers, where they are reduced to distribution voltages of 6,600, 4,600, and 2,300 volts. This distribution voltage then gets reduced or stepped down to utilization voltage that the customer uses at voltages of 440, 220, or 110 volts. Transformers are highly efficient at full load, with efficiencies running 95% or greater. Physical construction of transformers. In the three-phase transformer, the windings are tightly housed in some form of sheet metal container. A layer of insulation will separate the windings from each other and from the housing. The coils sit between a layer of insulation to keep them separated while still allowing magnetic induction to occur. The housing will be filled with oil or a synthetic fluid that serves 2 purposes. One, to keep the transformer cool, and the other as an additional insulating material. You may see transformers with corrugated sides to provide additional surface area for cooling. The heat is transferred from the core and windings to the oil and then to the shell of the transformer, where it radiates out to the atmosphere. The electrical leads penetrate the transformer housing with protective bushings of porcelain or oil-filled and capacitor types for high voltage applications. Step-up and step-down transformers. We mentioned that the voltage at the power plant is stepped up to increase the voltage for greater efficiency when transferring the power over long distances. This is because higher voltages require less current or amps, which means smaller wires for transmission, which equals less cost for transmission. The step-up transformer increases the voltage while decreasing the current. This is done by having more turns of the coil windings on the secondary side compared to the primary, as indicated by the turn ratio. The step-down transformer decreases the voltage and increases the current. This is done by having less turns of the coil windings on the secondary side compared to the primary. A transformer receives electric power in its primary windings and transforms it into electric power in the secondary windings of the same frequency. The voltage can be increased or decreased, but will have a proportional decrease or increase in current. How a transformer works. The transformer has two circuits, a primary coil winding and a secondary coil winding linked by a common magnetic flux. The primary and secondary windings are separate coils but are magnetically linked. When current flows through a conductor like a wire, a magnetic field is created around the wire. When a bunch of that wire is wound closely together, like in a transformer, then the magnetic field becomes much stronger, allowing for the transfer of power by magnetic induction from the primary coil to the secondary coil. This magnetic field induces a current to flow in the secondary side of the transformer if the circuit is closed. The alternating current will push and pull on the electrons, causing the current to flow. If you like that video, please give it a thumbs up and subscribe to our channel. Thank you.